This is a lecture about how to use conversational AIs or virtual assistants more effectively. These conversational AIs have a core large language model, which is a device for guessing the probability of what word comes next on the basis of a large amount of training data. There are two major steps in between this large language model and the conversational AI or virtual assistant itself. First, there's reinforcement learning from human feedback, or RLHF, which is supposed to make the responses more helpful, harmless, and honest. And then furthermore, there's a system prompt that is built into it that so that the LLM doesn't just continue as though it was finishing a text that you started, but instead responds to you like another person in a conversation with you. Thinking about all of this can help you understand both what other people might be doing to get more use out of these and what you can do for whatever it is that you're trying to do with one of these virtual assistants or conversational AIs. At the time I'm recording this video, August 2024, it's just over a year and a half since OpenAI released ChatGPT, the first one of these systems. But every few months in that time, there have been new systems released by competitors, updates to the existing systems, changes in the interface, and so on, both for paid users and for free users. So I won't focus too much on all the details, but instead on more of the conceptual issues of how to use these systems more effectively. Now, one thing I want to emphasize, in any conversation with a large language model, you are the most important conversation. You are the one whose interests matter. Your strategies should be structured just as much to get good results out of you as out of the large language model. If the conversation gets off on the wrong foot and goes in the wrong direction, it's easy enough to reset the LLM so that it forgets the whole thing and gets started better the second time from a blank slate. But you can't do that yourself. Uh, this is why professional writers and mathematicians and puzzle solvers and all often put down their project for a long time, whether it's hours or weeks, depends on what they need, what it is, so that they can forget what they were thinking and come back to it with fresh eyes. You may not have time to do that for whatever it is you're working on. So remember, if it matters what's going to come out, you should always start by doing some of your own brainstorming about what issues you want the conversation to cover and write down that checklist. If you engage with a large language model, it'll suggest some ideas of its own. And if you haven't already come up with your ideas, then its ideas will replace yours. You need to be the boss, not it. Okay, so now the central feature is that a large language model uses the transformer and attention architecture to look back at the context and generate the text. The two big types of things that affect the text that it generates are the context and the model. And I won't really discuss the system prompts and the fine tuning all that much. At the moment, I believe that these aspects are only under control if you're a paid customer and not on all of the different systems. Now, both of these things, manipulating the system prompt or fine-tuning the model, are mainly going to be useful if you want to set up some sort of app, such as like an automated system that sends a call to the large language model to generate text in a systematic way. So, for instance, some researchers at the Pew Trust did this they wanted to use ChatGPT to go through the descriptions of 20,000 podcast episodes and use its language model to figure out which names in the various descriptions are the guests, and then extract that into a file that a normal computer program could work with systematically. And they needed to modify the system prompt to make sure that ChatGPT could do this effectively rather than having a conversation. This could also be because you're generating an app as a system for other people to interact with. So for instance, South Korea Telecom trained Claude to go through the records of customer service calls and summarize issues and action items to help human customer service agents more effectively address the issues that the customers were having. And so South Korea Telecom needed to add extra training beyond the initial training data and beyond the general RLHF that the chatbot had to make sure that Claude was paying attention to the right aspects of the customer calls. Okay, another set of things I'll briefly mention is the choice of model and temperature. And when I say that a large language model guesses the probability of what word comes next, I should be a little bit more precise. The neural net doesn't directly output probabilities for each word, but instead generates something more like a score, which gets converted to a probability. So here's an example of what it might be considering. So for instance, maybe it's got these words as its only context. After dinner, I ate. And here are some possible continuations. And the neural net is trained in such a way on the basis of all the data, it'll probably rank some of these continuations as good ones and some as bad ones. The simplest idea would be for the LLM to always pick the answer with the highest score. In this case, that would be dessert. But we don't always want the most generic text to come out. And instead, sometimes we want it to produce other reasonable words with somewhat lower score in order to say something a bit more interesting. So instead of always picking the word with the highest score or the maximum score, they instead use this function they call softmax to pick among the words with relatively high scores at random with some amount of probability. The highest scoring word always has the highest probability, but they can vary how much does the probability of the word depend on the score. And this is a parameter that they call temperature. And it's borrowing this idea from thermodynamics that higher temperature is related to chaos. So at the lowest temperature of 0, the softmax function actually becomes the hardmax function. It always picks the word with the highest score. But if temperature goes up, it might become a bit more likely to pick words that are slightly lower score. And if the temperature is even higher, more of that probability gets sent further down the list. Uh, and then no matter how they do this, the highest score word is always the most probable, but how exactly that probability varies and how much probability is given to words very far down the list can get higher as the temperature goes up. Now, most large language model systems don't let you pick the numerical temperature setting directly, but they sometimes allow it indirectly, often using words like creative for high temperature and precise for low temperature. And as an example, here I'm showing the start screen for ZotGPT, which is a version of ChatGPT that my university, University of California at Irvine, has licensed specifically for our own internal use. And this terminology of creative versus precise is very suggestive. If you have a choice of temperature, you might want higher temperature for things that you're trying to create more unusual and interesting responses for, and lower temperature for responses that are supposed to be more precise and authoritative. Are you using the LLM to brainstorm and try to be creative, or are you trying to use it as an encyclopedia to get the standard solution to a problem? And this applies if you're trying to use it for computer programming or math or whatever too. Sometimes you want the more out there and brainstorming idea. Sometimes you want the more standard one. Now, in terms of the model, most of these systems don't directly let you choose which model you're using unless you're logged in with a paid account. But just so you know, currently, these different systems have different models that exist. So ChatGPT's highest end model is currently 4.0, which is literally a lowercase letter o, not the digit 0. And they have a smaller version, 4.0 mini, and their older version, GPT-4, which involves a turbo and a regular version. For Claude, there's a large model, Opus, a medium-sized model, Sonnet, and a smaller model, Haiku, named after poems of different sizes. And all of these exist in their current 3.5 form and their previous 3.0 form. And Google's Gemini system has these Ultra, Pro, Flash, and Nano forms. And it's currently releasing the 1.5 level of some of them and still has the 1.0 versions of all of them. And most of these services are not releasing all the details of the differences between these models, but in general, the higher end models have bigger neural nets with more layers, more neurons, and are trained on larger amounts of data. And so very likely for almost any purpose, you'll get better and more informed and more interesting responses with the higher end model, though it might take a few seconds longer to respond than the lower end model. And more importantly, the higher end model takes more energy and computational power, not just to generate, not just to train the model, but also for each individual call. And that doesn't show up directly to us, but the companies generally won't let us use the highest end model unless we pay them for that energy and computational power. So in general, you'll probably want to use the highest power model that you can, unless you are limited by budget, or if you're trying to use the large language model in some sort of app or other setting where you really need the responses to come quickly in fractions of a second. Now, the prompt itself is something that many different people will give you feedback on and give you advice on how to pick. There's lots of different articles and videos on the internet about how best to structure prompts. It can sometimes be useful to tell the system to think step by step or to explain its work and to tell it what kind of audience to write for, what sort of persona to take on, and give it several examples of the kind of thing you're trying to do. But I generally think that unless you're trying to create a single prompt that can then be automated within another application that calls a large language model, it's generally just going to be better to make sure all of this ends up in the general context. You don't need it all to be in a single prompt. And part of this is that all of the models, even the very lightest weight ones that exist right now, uh, have context windows of tens of thousands of tokens or dozens of pages. That means that anything that's in that much of the recent conversation is still there and still being paid attention to by the model as it generates new responses. And some of them, Gemini claims to have a context window of over 1 million words, which is actually the length of all 7 Harry Potter books put together. So unless you're going to have a very long conversation, the large language model is going to continue to remember the early parts of the conversation. And so you can shape it through multiple prompts and multiple responses to hopefully be more helpful for what it is that you're trying to do. Now, once you've started this conversation, you might try telling it to think step by step so that it explains its reasoning. And you might try telling it to write for a different level of audience. Maybe you want it to write for a college student. Maybe you want it to explain for a 5-year-old. Maybe you want to describe yourself in some other way, or maybe not yourself, maybe your other audience, make sure that it gives most helpful responses. You might try to tell it to act like a different sort of person, either because you're trying to get it to write a certain kind of email, or because you think you might get better results by hearing something from someone with a different personality. Uh, if you're a doctor trying to get information to your patients, you might tell a large language model to talk like a doctor who knows how to be empathetic and explain things well to patients. Uh, and another thing you might want to do is give it some examples of the kind of thing that you like. Don't just ask it for, write an email about whatever. You might say, here are some past emails that I think have worked well. Write another one like these. Or instead of asking it for a review of a video game, you might give it an example of a video game review that you found helpful and ask it for a new one in that style. Or if you're trying to get it to solve a certain kind of math problem or do a certain kind of estimation or computation, you might give it some examples of past ones that you thought were effective. And now, one flip side of all this is that because of this very long memory and context window that the large language models have, once you mention an idea in the conversation, that idea will remain and will keep influencing what it's thinking and what it's saying in future rounds. So sometimes a very important tool is to start a new conversation with a large language model so that it has no context, or so that you can shape the context in a very different way than you did before. Sometimes it's valuable to have multiple separate conversations going, tracking different versions of the context. If it says something once that isn't helpful, sometimes it's better to start over and get a way for it to say useful things before it says the bad thing, because otherwise it might try to copy that bad thing later on. Now, one other thing to remember, it's not just that the large language model is a context machine that is influenced by everything that came before. But you are also a context machine, and you will keep coming back to ideas that have already been suggested in the conversation. And unlike the large language model, you can't just click a button to forget everything that you've heard and brainstorm again from a blank slate, unless you put the project down and work on something else for long enough to forget what happened in this conversation. If brainstorming or creativity is going to be valuable for your project, you should do that before you interact with the large language model and write down all your ideas, whether good or bad. You can then have one conversation with the large language model where you talk about the ideas that you started with and see what it says about them, and maybe a separate conversation where you ask it to brainstorm from a blank slate to see if it thinks of any ideas you didn't think of. Now, in general, an important feature is that although a large language model is definitely not a human, it often responds better to the kinds of interaction and control that you have with humans than with other computer programs. It's not a symbolic system that follows simplistic rules. It's a neural net that makes associations and guesses and has intuitions and instincts. You have biases and it has biases. When you're working with another person, you can often think about that person's biases and their emotions and their advantages and their disadvantages and make use of their comments even if you don't fully agree with them. When you're working with another person, you don't always ask them to generate the final product that'll be submitted. You can take what they produce and edit it. And equally importantly, you can then take your version and give it to them to edit. Going back and forth several times often makes the best written product. When you're working with another person, the two of you often have different plans for what you're trying to do with a document. With a human co-author, both plans matter, but with a large language model, only your plans matter. So you should make sure that you have an idea of what your goals are before you go in. If you're a student or an employee who's trying to produce something for a professor or a boss, often their plans are the ones that matter, not yours. But if you're working with a large language model, that often gives you some breathing room to step back from the details of picking each word, and you can think, what would make this assignment not just valuable for the goals that the professor or boss has set, but for the goals that you actually have? Why are you taking this class? Why did you think this job was a worthwhile one to do with your time? Maybe you can shape the document to be not just effective for what the professor or boss wants, but also effective for what you're trying to do. Figuring out your goals and telling them to the large language model can sometimes help it produce things that are better for your interests. Sometimes it's worth not telling it that. Sometimes it's worth seeing what it produces without knowing your goals. And it may help you realize that another goal is also worth pursuing. But you should think about your goals first. If you don't do that, you will often find that you are working for the robot, that it came up with the goals and made you work towards them. You want to be the boss, make the robot work for you. Now, returning to the set of things that can be used to shape the output, one last thing is that you can upload extra documents for a large language model to access. So in ChatGPT and Claude, there's a paperclip icon somewhere near the chat box that allows you to upload a file at any point in the conversation. With this ZotGPT service that we have at UC Irvine, you have to do it at the start of a conversation rather than in the middle of a conversation. Google's Gemini system currently only lets you upload images unless you have a paid account, but the other ones also allow you to include text documents or spreadsheets, and paid accounts allow you to include much larger files, often much larger than the context that it can remember. And one way to think about what you're trying to do here is that a basic large language model is like a person who has studied everything, but now has to answer your questions from memory. If you upload a document, it's like taking this knowledgeable person and giving them some books to work with. Even if they've read the book before, having it available in front of them will let them find specific passages from it and will let them analyze it. What exactly the information is that the large language models can extract from a file is not always clear, but you can take advantage of their broader language processing abilities to find passages that talk about particular themes or ideas, rather than the ordinary find feature that you might use in other programs that looks for precise text. This way, the system can summarize and explain these passages rather than just identify every single place where a specific word was used. Hopefully, you find some of these techniques helpful, and you should explore and learn more of your own.